when I said that there's only two types of graphs, like trees and cycles, that's obviously ignoring, or in that case, it's just all undirected graphs, right?
Mhm.
So if these two edges are connected, if there's an edge here, then either of them are connected. But directed graphs are different. Like, sure, you can still have trees, but this will not be a cycle.
Uh,
When I try to do this, I like normally think of them as having like two edges. Like for a bidirectional graph, it's two edges. For one, it's just a single edge, but that's just the algorithmic way of thinking about it. So in this case, we have graphs that basically just have, well, these are just node numbers, and then you just have the weights. The most common case that you'll deal with, especially in Silver, is where the edges all have weights, but they don't have negative weights. So all the weights are positive or zero. And then like the types of problem you'll face most likely say like find the shortest path from here to here or some variation of that. BFS and DFS are like the simple ones where you don't have edge weights, right?
mhm.
But when you have edge weights, it becomes a little bit more complex.
Um,
What happens then is instead of just calculating edge weights, or instead of just doing BFS, you have to consider edge weights, which involves a priority queue instead of like the normal queue that we had before. And then we have to use an algorithm called Dijkstra. But I don't think, I'm not sure if we covered that today. We probably cover it next class. So in code, you definitely cannot store a graph like this.
mhm.
You have to turn it into some kind of, you know, either a table or a JSON list. This is simple. It's just a 2D array, right?
Mhm.
It's really simple because you just have to say, boop, boop, these are connected as edges.
Mhm.
But as you can see, there's a lot of wasted space. All the zeros here are the ones that it's just all wasted space. And let's see if you have like 10,000 nodes, right? Then 10,000 squared in adjacency matrix is already taking up all of the memory that your code can be allocated. So this just doesn't work when your graph has a lot of nodes. That's why this kind of adjacency does the right name. And since we are learning with C++, in that case, it's called a vector.